Hello and greetings to all the guests and speakers. My name is Nikita Chen-iun-tai. I am the founder and CEO of Apis-Cor company. We are developing and producing technical solutions for construction 3D printing. It is a great honor for me to have the opportunity to share my knowledge, experience and vision of 3D printing industry development with you. 3D printing has been known to the world for a long time. You can print these materials such as plastic, metal, ceramics and even glass. These products are used in healthcare and other industries, but few people know what construction 3D printing is. A house consists of many parts such as foundation, walls, windows and doors, ceiling, roof, plumbing and wiring. And no company prints whole houses. When we say to print a house, we only mean printing walls of a building, because the printer doesn't yet participate in other processes. Construction 3D printing started with large printers beginning to print individual building elements, and then these elements were assembled on a prepared construction site. However, these printers are large and cumbersome, have a portal design, have limits on the height of printed building, and are not easy to transport and assemble. That's why this approach has not made a revolution. Our team was able to take the first step towards full mobility using a construction crane principle, which allows for printing of building walls directly in place. Take a look, the walls of this house were printed completely on site. It is the world's first actually printed house not assembled from printed panels. Now, even though this building was constructed directly on site, printing roof and floor slabs is technically difficult so far, because this means printing horizontal structures. When you print this plastic, this issue is solved by printing supports, which are later removed. However, in case of concrete printing, this is not possible, as removing concrete supports is not an easy task, and roof separately, then their subsequent assembly is inevitable. But I personally do not like this approach, as it is contrary to our main idea. Printing must be done in place, without additional assembly works, full automation, no cranes, slingers and other personnel, because this is a very dangerous job. I really believe that construction 3D printing can heavily replace traditional construction. At the moment, traditional stone construction of blocks and bricks is the most threatened one. Firstly, Apis-Cor and other companies print using a mixture of cement and sand. So, a printed house is not any different from a concrete house. The printer is just a way of laying down the material. The only difference is that the printer is a robot, an automated system which eliminates the human factor. Therefore, concern about the durability of printed houses are not justified. Secondly, 3D printing makes building concrete houses cheaper. To see this graphically, let's take a look at all the processes that are necessary for walls construction. Blocks are first manufactured in the factory, where people and production equipment are involved, and then these blocks are moved to the site and unloaded, using manual labor and special machinery. The construction team then lays the walls brickwork for about 2 months, and this is a rather laborious process. Using a printer replaces more than half of these processes. The material is already in place, and a printer controlled by a single operator constructs walls in a few days. Using 3D printing equipment, you reduce logistics and manual labor, remove intermediaries in the supply chain. And that's why 3D printing cannot cost more than the traditional approach. Let us not forget the additional benefits, such as lack of waste, time savings and new architectural capabilities. I think everyone knows that the brick and block industry is a very large multi-billion market. So, if you have shares in companies which produce bricks and blocks, you can already start thinking about selling them. I think it is going to be a surprise for many. Perspectives and possible solutions are beautiful things that compel us to move forward, but we have a lot of work to do today. For this technology to become popular and to actively enter the market, we need to solve many problems that lie in entirely different areas of science. I see two major challenges here. At the moment, a hardware is a musical instrument that you still have to learn to play on. So we need to create a low-cost functional 3D printer that can work in complex operating conditions. We need to bring the degree of automation of the 3D printer to the maximum to reduce the skill requirements of the operating personnel. The technology is at the intersection of software and mechanics. The first challenge is the amount of engineering. Developing a mobile construction 3D printer is as complex as developing a car. And as you know, in 100 years there hasn't been a successful automobile startup, except for Elon Musk's Tesla. The second challenge is to make the construction 3D printing understandable to designers and architects, since any construction starts with a project. As far as I know, there are no methods for the calculation of printed structures yet. To address this problem, we need to research printing materials and their properties, which will then become the basis for the project design calculations. We are now actively working on this task and have the following objectives. By the end of 2018, provide a solution for printing entire houses, foundation, slabs and roofs. By 2019, develop a solution for using 3D printing in high-rise construction and also increase the degree of automation to the maximum, making the equipment almost self-contained, bringing us closer to our dream of building beyond the boundaries of our planet. Thank you.
Ladies and gentlemen, Nikita Chen-iun-tai.